The goal of this video is to demonstrate the new automated multi-fiber inspection solution. Before diving into the demonstration of this new product, I would like to highlight a few features. The first feature is the fact that this tip is very slim. As you can see, it is almost the same width as an MPO connector. So if you deal with very dense panels, this inspection solution will fit very well. As you can see also, the position of my hand allows to clear recessed panels, so reach deeply recessed connectors. And also, if there's fiber management on a panel, I will clear it as well. As you can see, there is no scanning knobs on either side. That means that I can physically fit in very dense panel without having to put my hands to manipulate knobs. As you can see, there is no scanning knobs on this solution. If we look at legacy solutions, like this one, which is basically what you'll find on the market today, there is scanning knobs on this. One for the fiber, one for the row in this example. So physically, I have to operate this tip and scan those knobs from fiber to fiber, capture them individually, count the fiber, make sure I don't miss one, and then my inspection is done. This whole process takes a lot of time, and there's risk of errors, risk of skipping a fiber. Plus, you have to physically put your hands on either side of the tip to hold it and scan the knobs. So if you deal with dense panels, well, this solution is simply not compatible or very hard to use. If you think about very dense panels, like the 1U rack, for example, this solution will not fit into those situations because of the size, the physics size of the tip. While this here, being very slim, will fit very well into those dense panel situation. Today we're demonstrating a Wi-Fi inspection probe on an Android tablet. We'll also support iOS or Xfos instruments as well as PC. Let's launch ConnectorMax Mobile here on the tablet and begin the demonstration. When we launch ConnectorMax Mobile, it will connect to the inspection probe. Right now it is connected wirelessly through Wi-Fi, and the LED is blinking, telling me that this probe is ready to do an inspection. But before doing so, we must set a few parameters in the software because we're using pass-fail automated software analysis. As you can see here, where the fiber that we'll use for the demonstration is a multi-mode one. We can see the aqua color. And the ferrule size is 2x12 ferrule configuration. I could also inspect APC connectors, 16 fiber rows through the swap of a nozzle on the tip. So this black part here can be removed easily through this retaining nut, and you can convert from UPC to APC. This is an APC nozzle, or from 12 fiber to 16 fiber row configuration, and other multi-fiber inspection, multi-fiber connector that exists on the market today. So now, instead of changing the nozzle to go from male to female, we came up with this simple coupler, which basically convert this tip to inspect this jumper. So I'm going to use that, click on it, like that. Now my jumper is ready to be inserted on this fiber inspection tip. As soon as I insert the jumper, the autofocus will start, automatically adjust. And once this is done, I'm ready to do a capture. As you can see, there's an icon here blinking. This is telling me you're ready to do the capture. I just press the button on the probe and do the capture. Now it's telling me go to the second position. As you can see, there's a trigger under the inspection tip. Just pull on it. There's a click that tells me stop there. And I click on capture again. Now it's ready to do the third image, the last one. I go there just by pulling the trigger, click on capture again. As you can see, it took just a few seconds to do all the manipulations. Right now, it's all a matter of analysis and software crunching time. The advantage of this solution is, first, as you can see, I inspected in only three images, so 2 clicks, a 24 fiber MPO connector in just a few seconds. In fact, could have done it way faster than this, but I took the time to explain it through this video. Then it's just a matter of letting the software do the analysis. Right now we're using a Wi-Fi probe. All the crunching, all the analysis is done on board, on the probe, into an internal processor. So basically, each time you see the LED blinking, it is analyzing a fiber, sending the result to the tablet. With USB probes, the process will be quicker than this, because the processing will be done on board on the PC or the fiber instrument from Exfo. But for smart devices, the analysis is done on board on the fiber inspection probe. So basically, all the manipulations are done. As you can see, it counted all the fibers. There's number from 1 to 12, from 13 to 24, the second row. I can swipe through fibers like that on screen, or from rows to rows as well. This one is being analyzed at the moment. We just fell on the exact fiber that it was analyzing. So I can scan from rows to rows like that, or from fiber to fiber. I can also use the view in the bottom of the image to go directly on a fiber. Let's say I want to go to fiber 12 because I see it's failing here. Just touch 12 and boom, I'm right there. I see what's the problem. I see this fiber has a few scratch. So this is most probably a damaged fiber which cannot be used. You can scroll from fiber to fiber like that very easily through this view here, or through swiping, which is very common using a smart device. So right now the analysis is almost done. For a full 24 fiber, as you can see, it's error-free. Took just a few seconds in manipulation. No chance of missing a fiber. Very easy to use. So at the end of the process here, we'll see all the 24 fiber being analyzed. We're at the end here at the last one. So as you can see here, it's saying fail. This connector is failing because there's a few fiber failing. But we can quickly see which one are failing. We see number 2, 10, 11, 12, and 22 are the fibers that are failing right now. And we can clearly see why here. There's defects on each of these fiber, and the one passing here are these ones. So very quick demonstration of this new solution. So thank you for listening.